Hi everyone, in the second part of 6.7 notes, I'm going to teach you how to find the 6 trig functions using a point on the unit circle. So let's say we have, let me get rid of this circle first. At this point we don't need it. So let's say we have this coordinate plane and a point on this coordinate plane like P. This point P has coordinates like X and Y. So if I draw a straight line from P to the x-axis, then this horizontal line is my x-coordinate and this vertical line is my y-coordinate of the point P. If I draw a straight line from P to the origin, then I'm going to have a right triangle here. The angle which is made with the x-axis, I'm going to call that theta and work on this angle to find all the 6 trig functions of this angle. Notice in such a case we only take the angle which is made with the x-axis, not the one which is made with the y-axis, not here, only this one, like the reference angle. We only take the one which is made with the x-axis. Okay, so here the first thing that I need to do is to find the r value. If I have a right triangle that I have x and y on that triangle, like two legs, to find the hypotenuse, I can use the Pythagorean theorem. So it's x squared plus y squared radical of that. So this is the hypotenuse. Then to find sine of this theta, I need to divide opposite by hypotenuse. Opposite side of theta is y, and the hypotenuse is r. Cosecant is the reciprocal of sine, so that will be r over y. Just flip y over r. Cosine is adjacent over hypotenuse. So to find that, take the adjacent side, which is x, and divide that by r, which is the hypotenuse. And secant is the reciprocal of that, so that will be r over x. Tangent is opposite over adjacent. So this is y, which is my opposite side, over x, which is the adjacent side. And cotangent is the reciprocal of tangent, so this will be x over y. Now let's consider that we have a unit circle here on the coordinate plane. This is my unit circle, and point P is a point on the unit circle, like here. In a unit circle, the radius is always equal to 1. That's why we call this unit circle. So the radius on a unit circle is always equal to 1. Now, in this case, that the r is equal to 1, we are trying to find the sine, all the trig functions of this angle theta. So if we have a unit circle and r is equal to 1, then let's see what happens to all these 6 trig functions. Then sine of theta will be y over 1, because r is equal to 1. Y over 1 is just y. Cosine of theta will be x over r, which is x over 1. So that's just x. Tangent of theta will be like the same thing because we don't have any r involved here. So it's just y over x. Then cosecant of theta is 1 over y. Secant of theta is 1 over x. Just replace r with 1. And then cotangent of theta is not going to change. It's just x divided by y. Basically, what I'm trying to say to y'all is that if you have a unit circle and a point on the unit circle that has coordinates as x and y, this x is actually cosine of theta, and this y is sine of theta. So I can rewrite the coordinates as cosine of theta and sine of theta. Once again, if you have the unit circle and a point on unit circle, the coordinates of that point are going to be cosine and sine of this angle theta, which is made with the x-axis. We can make another conclusion from what we just did here, like all these stuff that I explained to you. We know that tangent is y over x. And we just learned that y is sine of theta. And also x is cosine of theta. So tangent is sine over cosine. What is cotangent? That is x over y. X is cosine of theta and y is sine of theta. So cotangent is cosine over sine. These are very important. I need you all to memorize this. Tangent is sine over cosine and cotangent is cosine over sine. Now let's talk about the signs of trig functions in the different quadrants. So if I have this coordinate plane, we're going to see the trig functions that we have, like sine, cosine, tangent, and so on. What sign are they going to have in each quarter? So let's say we have a point on the first quarter. So we make the angle that we need. This is the angle which is made using this point, and we call that theta. So if I draw the vertical line to this point, we know that x is this line and y is this line. So this point has x and y coordinates, and we know that x is x is cosine and y is sine. So based on that, I'm going to figure out what are the signs of sine of theta, cosine of theta, and tangent of theta here. Okay, sine is y, and this y, because it's above the x-axis, is always positive. So sine of theta is positive. Cosine of theta, this x is also on the right side of the x-axis, so this is also positive. Tangent is sine over cosine. That means positive over positive. That is positive. So in the first quarter, all the functions are positive. How about the second quarter? If I have a point here and I make my angle, again, my theta is going to be this angle, which is made with the x-axis. Notice it's not this one. It's just this one, which is made with the x-axis. Okay. So I draw my straight line here. This is y and this is x. But here's the point. On the second quarter, y is positive by x, but x is negative because it's on the left side. All the values on the left side of this 0 are negative. Okay, so sine of theta will be positive because it's y and it's positive, but cosine of theta will be negative because x is negative and cosine is equal to x. Okay, so cosine is negative and tangent will be positive over negative, which is negative. So in the second quarter, sine is positive, but cosine and tangent are negative. What if I have my point in the third quarter? I draw my line. The angle that I'm working on is going to be this one, the one which is made with the x-axis, not the one which is made with the y-axis, only this one. Okay, again here, this is my y and this is my x. And In the third quarter, both y and x are negative because this is below the x-axis and this one is on the left side. So these are both negative. That means sine of theta is negative. Once again, why is this sign negative? Because sine is equal to y. Sine of theta is equal to y, and y is negative, so sine is going to be also negative. Cosine of theta is equal to x, and this x is negative, so cosine is also negative. What is tangent? Tangent is negative divided by negative, because tangent is sine over cosine, so it will be negative over negative, and that is positive. So in the third quarter, sine and cosine are negative, tangent is positive. In the fourth quarter, over here, again, the angle which is made with the terminal side and the x-axis. This is called theta. Okay, let me fix this. This is our angle theta. And if I draw my straight line, this is my x and this is my y. X is positive because it's on the right side, but y is negative because it's below the x-axis. So this means sine is negative, cosine is positive, and tangent is negative divided by positive, which is negative. So you need to remember all these signs. So you need to know the trig functions. What sign do the trig functions have in each quarter, actually? To help you remember these, I'm gonna teach you this phrase. All smarties take calculus. So we always remember this phrase. All, the first letter of all is A. That stands for all. That means in the first quarter, all the trig functions have positive sign. They're all positive. S for Smarties, that stands for sine. This means in the second quarter, only sine is positive. As you see, only this one is positive. Third one, take. The T stands for tangent. So this means in quarter 3, only tangent is positive. And calculus, C stands for cosine. That means in quarter 4, only cosine is positive here. Only cosine is positive. So if you remember, all smarties take calculus, you know that in the first quarter, all positive. Second one, sine is positive. Third one, tangent positive. And last one, quarter 4, only cosine is positive and all the others are negative. Okay, so now let's work on these problems. We are going to find the 6 trig functions of theta if the terminal side of theta passes through these points. Let's work on the first one. Okay, so this is the coordinate plane. And -1 and 3 is going to be somewhere like this, -1 and 3. So the point is here. This is the point -1 and 3. So to find the theta, first of all, you are going to draw a straight line from this point to the origin. So straight line to the origin, which my line, of course, is not straight, so I'm going to draw it again for you. Okay. Straight line from the point to the origin. The angle is going to be this one. This is my theta, the one that I'm going to find 6 trig function. Then a straight line this is the x value, which is -1, and this line is the y value, which is 3. Now to find the 6 trig functions of theta, we're going to do the same thing that we did here. First of all, we find r. R is this line, the hypotenuse. R is equal to x squared plus y squared. So this will be -1 squared. Make sure you put that in parentheses and then raise to the power of 2. Because if you don't, and just without any parentheses you put in your calculator, it's going to give you the wrong answer, not the one that you're expecting. And 3 squared. That will be -1 squared is 1, and 3 squared is 9. 1 plus 9, which is radical 10. If you don't put this in parentheses, you're going to get this from your calculator. -1 squared plus 3 squared. It will give us -1 plus 9. And that's radical 8, which is not the right answer. Radical 10 is the right answer. Anyway, so we found r. Now, sine of theta. Sine of theta is opposite over hypotenuse. So it's just 3 divided by radical 10. It's actually y over r. I'm going to write that here. Y over r. The y is 3 and r is radical 10. Cosine of theta is x over r. That is -1 over radical 10. Tangent of theta is y over x. Y is 3 and x is -1, so that will be -3. Now the reciprocal functions. Cosecant of theta will be, just flip 3 over radical 10. That will be radical 10 over 3. Then secant of theta is flipped form of this value, which is radical 10 over -1, which is just negative radical 10. -1. And then cotangent of theta is reciprocal of 3 over -1. That is -1 over 3. And that's it. Now let's practice the next one. Let's work on the next one. Okay. So this time we have the point, the coordinate of this point as -5 and -7. So this is my coordinate plane, and the point -5 and -7 is going to be, let's say this is -5 and this is -7, so the point is going to be somewhere like this, -5 and -7. Then you draw a line, a straight line from the point to the origin. Then you're going to draw a straight line from the point to the x-axis, not to the y-axis, only to the x-axis. Then we have a right triangle here, and the angle that we're working on is this angle, theta, not this one, not the one which is made with the x-axis, the one which is made with the not the one which is made with y-axis, the one which is made with the x-axis. Okay. So the x value is -5 and the y value is -7. Now I'm going to start finding the trig functions. First of all, I need to find r. R is going to be x squared plus y squared, and we take the square root of that. So this will be -5 squared. Notice again, I need to put both of the negatives in parentheses. Whenever you have negative, you need to put that in parentheses. Then like this. And if you calculate that, this is 25, this is 49, so that will be 74. Square root of 74. You can go ahead and find a decimal number, which is 8.5, or just keep it as radical 74. Doesn't matter which one you use, both of them are right. Okay, now I'm going to find the trig function. Sine of theta is y over r. So what is y? It's -7. R is radical 74. Cosine of theta is x over r, which is -5 over radical 74. Tangent of theta is y over x, which is -7 over -5. That is just 7 over 5. Then cosecant of theta, that's reciprocal of sine, so that will be radical 74 over -7. Then secant of theta, reciprocal of cosine, which will be radical 74 over -5. And then cotangent of theta will be reciprocal of tangent, which is 5 over 7. Okay, so this was today's lesson. I hope it was helpful for you. Have a good day.